Okay, gas prices are getting higher and higher and higher, and most of the time we have this interesting property that the 87 octane is 10 cents less than the 89 octane. This happens as they go up and down, they're always 10 cents apart. So something interesting happens when the gas price becomes $4.35 a gallon. Then it becomes, if you look at the cost per octane is cheaper for the 87 octane when the price is less than $4.35 per gallon. But when the price is $4.35 per gallon or more, then it's less expensive per octane to buy the 89 octane. So then the question becomes, should you buy 89 octane? And the answer is no. Even though it's less expensive per octane when we've crossed the 435 threshold, do not buy the 89 octane. It's only good for engines that are specifically designed for that kind of gas, and most of gas is designed for 87 octane. So it's sort of a meaningless threshold, 435 per gallon, but it is interesting to note that that's the transition point where if you look at the cost per octane, it becomes cheaper for the 89 octane over the 87 octane. Thank you very much, and don't buy 89 octane.
Why should you believe what I say? That's the beautiful thing about math. You don't have to believe me, you can just see it for yourself. So I'll just go over the mathematical proof. Okay, here's the proof of how this 435 per gallon number comes up. So the assumption is that the 89 octane is always 10 cents more than the 87 octane. So for example, if the 87 octane is that much, the 89 octane is that much. Or as another example, if the 87 octane is that much, the 89 octane is that much. So it's always 10 cents more. That's our assumption. So now if we look at the cost per octane, here's the cost per octane of the 87, and here's the cost per octane of the 89, where X is the cost per gallon of the 87 octane. So the 89 octane is 10 cents more. So if we solve this equation, we get X is greater than 435. So if the 87 octane is more than 435, the cost per octane is less for the 89 octane. Now the question becomes, should you buy the 89 octane? And that depends on your engine. Most engines are designed for the 87 octane. Now I'm going to tell you what is the definition of octane. Octane is the ability of a fuel to resist ignition under pressure. So high octane means we need a lot of pressure before the fuel ignites. Low octane means we need less pressure before the fuel ignites. So we define an octane of 0 to be the amount of pressure you'd need to ignite N heptane. Heptane means we have 7 carbon atoms, a straight chain N heptane. And we define an octane of 100 to be the amount of pressure you need for this compound to ignite. 2,2,4-trimethyl pentane. Pentane is 5. The main branch has 5 carbons. And trimethyl, we have 3 methyl groups at positions 2, there's 2 of them there. And at position 4, there's another methyl group. So that's 2,2,4-trimethyl pentane. So when you have a given fuel, you want to compare how much pressure that fuel needs to ignite to some combination of these two fuels. And so, for example, 87 octane means you have 87% this fuel, 13% this fuel, and the fuel in question requires the same amount of compression to ignite as that combination. But note that there are fuels that can have higher than 100 octane, which means it requires more compression to ignite than this fuel. And there are fuels that can have less than 0 octane. You can have negative octanes, which means they require less compression than this fuel to ignite. And that's the definition of what octane is. But it also depends on your engine. Your engine could be optimized for 87 octane, so buying 89 octane or more isn't going to serve you because your engine's not designed for it.